Greetings, students. It's lesson 80. And what we're going to do is operations with scientific notation. It's going to be fun. I'm going to start with multiplication. We don't usually add and subtract a lot with science. It's not as useful for that. It's more of a multiplication and division thing. So that's what we're going to work on. First, we'll do multiplication. That's what that X stands for, multiplication. Okay, example 80.1. We write the numbers 0.003 times the X and 2 times 10 to the 20th. Okay, John tells us to write these numbers in scientific notation and then multiply. Okay, so, all right, that sounds like a two-step process. I'm going to put parentheses around these to show that I'm multiplying them. John just writes them in sentence form, and that looks confusing to me. So, I don't want to do it like that. This one, proper scientific notation, doesn't it? Just the biggest digit is in the ones place. We don't happen to have any other digits, but that's fine. And then times 10 to the power of something. This is the one that's a little wonky because the decimal's way over here and the 3 is back there. So we want to move this decimal 1, 2, 3 times. So it'll be 3 times 10 to either positive or negative 3. And we ask ourselves, do we want this 3 to get larger when we go back to the actual number, or do we want it to get smaller? We want it to get smaller, so we put a minus sign, right? 3 needs to turn into that to be its actual number, and that's smaller. Okay, so now we've fixed this much. Now we have to take this into account. So we add times 10 to the minus 4th. We combine these by remembering our product rule for exponents. If the bases match, then you can add the exponents. So this becomes 3 times 10 to the minus 7. Okay, and then I'm going to recopy this so it's down here where we can get our hands on it. Now, to complete our multiplication in scientific notation, I think you've probably seen this before, but I'll remind you. The first step, we multiply the numbers. Now, I could say this, multiply the one-digit lead coefficients, but I don't want to say all that. 3 times 2 equals 6. And then step 2 is we combine the, combine the exponents. So here it's minus 7 plus 20, right? Because when we are using the product rule, we add the numbers. So it's minus 7 plus 20. That would be 13. And then step 3 is what I like to call art project, because all we're doing is just writing the answer so it looks cute. And so we would have 6 times 10 to the 13th. That is the product, or the answer to this multiplication problem. All right, so we multiply the numbers, then we add, or combine, I shouldn't say add, we're going to do other things. We combine the exponents, and then art project means we just write it so it looks nice. Okay, lesson 1. That was multiplication. Here comes another multiplication one. Last time my book was crooked. I apologize, you guys. I hate a crooked book. 80.2. Multiply. Okay, so this time John doesn't write as much. Oh, there's so many zeros. 0.00004. Well, we know this isn't good, is it? Times 10 to the minus 5. And we're multiplying that by, oh, John got really lazy this time, you guys. Look. Those numbers are neither in scientific notation, not even close. So, what do? We start fixing. We bump this decimal to where we want it. We want it right there. So 1, 2, 3, 4, 5. So it's 4 times 10 to the either positive or negative 5. The question we ask ourselves is when we make 4 go back to its original shape, like this, will the number get bigger or smaller? It will get smaller. So that's a neggy. A neggy, a negative. I think I can talk in English. Maybe. I think I can. Okay, so now we have to combine it with this other 10 to the power. And look, it's the same number. That's just weird. So this would be 4 times 10 to the minus 10. Okay, so now we fixed the first one. Now we have to fix this one. We want the decimal here. 1, 2, 3, 4, 5. And this becomes 7 times 10 to the either positive or negative 5. We ask ourselves, do we want the 7 to get bigger or smaller when we turn it back into its actual number? We want it to get bigger, so we leave that positive. Okay, so now we're ready for our 3-step finishing process. First, we multiply the numbers, so to speak. 4 times 7 equals 28. And then we combine the exponents. We're multiplying here, so that means we add the exponents. Negative 10 plus 5 equals negative 5. And then number 3, we art project, right? So it would be, there's our 2 pieces. We do 28 times 10 to the minus 5. Okay? That looks really good and that's correct, but hold the bus. We're not in proper scientific notation anymore. When we multiplied our 4 times our 7, we got a number that was bigger than just a digit in the ones place. So now we have to fix this. The decimal it's right here right now. We want it there. That means it has to move 1. So it becomes 2.8 times 10 to the 1. Is it positive or negative? We want this number to get bigger, right? We want it to go back up to 28. So we leave that positive. And now we have to recombine this bit. And our final answer is 2.8 times 10 to the 1 minus 5 negative 4. So, this is a little curveball that we can sometimes get at the end of a problem when the product we get when we multiply the numbers is bigger than a single digit answer. Last time we had 3 times 2, so it was 6. It was still a single digit. This time John pushed us out into the deep waters of scientific notation, you guys. And here we are, dealing with one more thing. All right? Okay, that is basic multiplication with scientific notation. Flip and straighten. Now we're going to talk about division. Example 80.3. John says in his language, he says it as a sentence, he says divide this number by this number. Looks really hard, doesn't it? I mean, 16 and 4 look like friends, but the rest of it looks like an exercise in guessing wrong. Okay, we do the very same thing. We write each of these numbers in scientific notation before we do anything else, proper scientific notation. This one is wrong. 1, 2, 3, that's where I want the decimal. So I'm getting 1.6 times 10 to the third, 3 jumps. Do I want this number to get bigger when I put it back, or do I want it to get smaller? I need it to get smaller, so there's my minus sign. Okay? This one is going in the opposite direction, right? Our decimal's here. 1, 2, 3, 4, 5. 4 times 10 to the fifth. Do we want this positive or negative? Do we want 4 to get bigger or smaller when we put it back into its original shape? Oh, we want it to get bigger, so we leave that positive. Okay, so now we have gotten everything top shape. Now we have our 3 steps again. This time, step 1, I think last time I said multiply. This time, for step 1, we divide the numbers. Okay, so we take 1.6, and we divide it by 4. Now, you might be able to do this in your head. I'm always super duper careful because decimals, I mean, I know 16 is divided, 4 times 4 is 16. That's easy. But it's getting the decimal in the right place that can be a real heartache. So I do it this way so I can really look at what I'm doing. I put a 4 up here. I feel better. So now my answer is 0.4. Step 2, combine the exponents. Now you know why I stopped saying add the exponents, because in this case we're not using the product rule, we're using the quotient rule, and that means we subtract, right? We're using the quotient rule, which is this piece of business, right? I didn't write the other one out, sorry. So then we know it's -3 minus +5. This is a good thing to bucket when you start having minus signs in your exponents, because we're subtracting 2 and things can go real crazy real fast. This one though is reasonable. It's -8. Okay? So I then step back together and I have this 0.4 times 10 to the -8. But uh-oh, we need to jump this one more time. 4 times 10 to the 1, is it positive or negative? When I put it back to its actual number, does this 4 get bigger or smaller? It gets smaller. Give it a minus sign. And then we combine it with that part. And so our final answer is 4 times 10 to the -9. -1 and -8 combined. That's, I'll write it now, because I don't want to neglect the product rule. X to the n times x to the n equals. Okay, so there's some puffy clouds of knowledge to make your life run more smoothly when you're doing these problems. Oh, this cloud is sadly lacking. Come on. Okay, so we learned that sometimes you have to adjust it to make a bigger number smaller. This time we made a smaller number bigger. Either way. Okay, are you ready for the crowning touch of this lesson? Because I am. It's my phone that's crooked on the chair. It's not my book that's crooked. That's what's driving me crazy. This time we're going to multiply and divide in the same problem. What? Are you kidding me? And we have 2 of these, just so that we understand really well. All right, copying 0.00. Sorry, I'm not going to say all those zeros. That will make you crazy. It's going to look hard, though. I'm just going to tell you that right now. Look at those zeros. They look jolly. 1, 2, 3, 4. Okay, I'm going to be double checking each of these numbers as I work on it individually, but you can see what we're having to do. We have to multiply, and then divide top to bottom. But we're going to do that all in one. It doesn't really have more steps. This problem doesn't. What we're going to do first is what we always do. Put it into proper scientific notation. You'll get better and faster at this. So if you have a process for going faster than I'm going, that's fine. I'm going to do it the painstaking way, just so that you have that in front of you as well. All right, I'm starting here. 1, 2, 3, 4. 7 times 10, it's the -4 because I need that to get smaller. Then 10 to the -23. Whoops, I wrote 8, but I meant 3. And so here we get, I'm going to write all my answers down here. 7 times 10 to the -23. Okay. Oh wait, 27. I didn't combine these, did I? I just copied this part. Minus 4 plus minus 23 is minus 27. I'm going to rewrite it so that we can actually read it. Okay, there's my first clump. Closing parentheses there. Okay, this one, I want to go 1, 2, 3. It'll be 4 times 10 to the positive 3 times 10 to the 6. That makes this 4 times 10 to the 3 plus 6 is 9. This should be a big parenthesis. All right, that's the top. Now we go ahead and do the bottom. We're not going to stop. Keep on keeping on. All right, 1, 2, 3, 4, 5. 4 times 10 to the negative 5. And 7,000,000, 1, 2, 3, 4, 5, 6. 7 times 10 to the 6. Notice that with these, when we get the actual number, in some ways that's better, because up here we always have to do the two-step adjustment. First this number, and then we have to combine it. But these don't have any powers of tens attached to them, so it's more of a one-step process. Okay, this now is all 4 of our numbers. I highly recommend that at this point you stop and check your work in the solutions manual to make sure you're on track, because no sense in going on if you have a little mistake in this. All right, so you've checked your numbers. Let me check mine. Minus 27, positive 9, minus 5, plus 6. Okay, great. Now, our process is exactly the same. It's just a little bit more complicated. So step 1, we multiply or divide 7 times 4 over 4 times 7. What? I'm going to make parentheses. Those dots don't look good to me. 7, 4, 4, 7. Look, they all cancel, and we just get a big fat 1. Come on, John. That doesn't happen often, but this time it happened. Step 2, we combine all of these using the appropriate rules. So we start with minus 27, then we add 9. I'm going to make buckets. Then we subtract this minus 5, and then we subtract 6. Okay? So the exponents are, oh, that's a 9. The exponents are exactly what we have written, and then I have pluses for the numerator and negatives for the denominator, because I'm using my quotient rule here. Product rule, quotient rule. Okay, so now I have to combine all of this. I'm going to work up here. I'm sorry. This is going to get confusing. I'm using this as my new work zone. I'm taking this up here. Minus 27. This becomes a plus. So I'm going to combine these two. That's minus 33. And this is plus 13. I knew something was wrong. And that will give me 19, if I did the math correctly. Yes. Okay, so we added the exponents for the numerator. We subtracted the 2 in the denominator. John does it in a slightly different order, but it still works out to the same answer. So our final answer, art project, is 1, I don't know why I like to make the fancy 1 there, times 10 to the minus 19, final answer. And that's correct. Okay? Woo, that was a lot. It was super confusing that I had to go up here. This is our step 3. Feel smart. Look, you guys, you took something like this and you turned it into that. That's pretty amazing. Well, you didn't this time. I did. But you will be doing it soon, and you will amaze yourself. Okay, let's do the last problem for this lesson. Example 80.5. and it's another beast. Now, when you get good at this, well, when you get really experienced, if you want, you cannot copy the problem out of the book. You can fix it in your head by looking at the book and then converting it and writing it down. Make sure you're accurate before you get too married to that approach. I don't even like to do it that way. It's too much to carry in your head and it's too easy to make a mistake. But I challenge to try that. Okay, 20 times 10 to the minus 45. These problems show up in chemistry, and they look exactly like this. So when you guys take chemistry, the other students are all going to be lying on the floor crying, and you're going to be like, I got this. This is not hard. John taught me everything I need. You'll think of me telling you that you would be doing this and that you will be good at it, and you'll remember this moment, you guys. Trust me. You'll remember this moment, and you'll be like, dang, she was right. And all the other students who for help with the math, and you'll be known as the genius. Okay, so we have the same problem we had before, fix. So let's do that. Let's start with this one. This should be one bump over, so that would be 2 times 10 to the 1 power. But then we have minus 45, so this becomes 2 times 10 to the minus 44. Okay, there's my first one. Second one. Oh, gotta go twice on this one. So this becomes 4 times, oh, I want to write it here. 4 times 10 squared, positive, times 10 to the 20. And so that's 4 times 10 to the, we add them, and we get 22. Good. Now I'm going to do something that's somewhat confusing. When I make my little notes, I'm going to go down, as maybe I'll just make them up here. Let's see what happens. But I want my final, not final, but I want my next step of numbers to be right here. This is 1 times 10 to the 1, 2, 3, 4, 5. It's a positive 5 because I want that 1 getting bigger. I like those because you don't have to do 2 steps. Okay, this one. 1, 2, 3, 4. This would be 8 times 10 to the negative 4, and then we combine it with the negative 15 by adding it. 8 times 10 to the negative 19. Yes. I just checked my answers in the book, which you can't see, but it's right here next to me. And we got all those right. Yay. Do give yourself the favor of that halfway step so that you don't keep going with bad numbers. All right, so now we pull all of the numbers rather than exponents for step 1, and we get 2, 4 over 1, 8. Oh, look what happened. 2 times 4 is 8. 1 times 8 is 8. 8 over 8 equals 1. John was a buddy and a pal again. He gave us another 1 to deal with. Thank you, John. That's really cute. Now we do step 2. Okay, we're going to put in 4 exponents. The first 2 we're going to add. The second 2 we're going to subtract. All right, we've got minus signs flying all over the place. Minus 44 plus 22 minus 5 minus, oh, come on, could that be? So now I'm going to write them with their signs straightened out. This will be negative 44 plus 22. Now I'm going to write the additional signs underneath them. This is minus 5. This turns into plus 19. Now I have minus 49 and plus 41. So that equals negative 8. Okay, that's my summarized exponent. This was a confusing one, so just be super careful. You might not want to use my exact format, although I do recommend it. I went through I wrote them with buckets, then I fixed them and wrote them so that the negatives were together and the positives were together, then I added. Okay, step 3 is art project. And there's my number, 1 times 10 to the minus 8. Yay, we got it right. That's the correct answer. When you look in the book at your practice problems, he doesn't give you any of the easier ones. He goes to this presentation like this where we're multiplying and dividing. Looks like, yeah, there's 4 chunks in each one of the practice problems. So they'll be like these last couple. And I hope some of them turn out to 1. All right, this is confusing. It's a lot of steps. There are lots of places to go wrong, so be patient with yourself. And I don't know if these kinds of problems for quite a while, so you'll have lots of chances to practice. Lesson 80 completed. Talk to you later.